Most scrapers start in the wrong place. Someone opens up a target page, hits view source, and starts writing CSS selectors against a wall of divs. Half the time that page was never meant to be read that way in the first place. It was rendered in the browser from a JSON response that's sitting right there in the network tab the whole time. Already structured, already paginated, and honestly a lot easier to work with than the HTML it eventually turned into. If you skip that step, you're doing extra work for a worse result. I run proxy infrastructure for scraping jobs at real scale, farms of residential and mobile IPs feeding scrapers that pull data all day, every day. One of the first things I check on any new target isn't the page markup at all. It's whether the site is quietly serving its own data as an API underneath and just letting the front end do the rendering work on top of it. That one check before you write a single line of scraping code changes how the whole job gets built. Here's why it matters. Rendered HTML is a byproduct. Somewhere upstream, a server returns structured data, and the front-end framework turned that data into the page you're actually looking at. When you scrape the DOM, you are reverse engineering a rendering step that already threw away structure the original response had. Field names turn into CSS classes. Nested objects turn into nested divs 3 levels deep. Numbers get formatted with commas and currency symbols that you now have to strip back out just to get a plain number you could have had for free. Query the underlying endpoint instead, and you often get clean JSON back. Typed fields, consistent keys, pagination metadata, sometimes even a total count sitting right there so you know exactly how many pages you're dealing with before you start. Parsing that is a fraction of the code compared to parsing HTML. And it breaks less often too, because HTML markup and CSS classes change every time a site gets a redesign, while API response shapes tend to hold steady for years, because other parts of the business, mobile apps, internal tools, depend on that same shape staying put. There's a load argument here too, and it's a practical one if you're paying for proxy bandwidth. A full page load pulls in every script, every style sheet, every image and font the page needs just to render for a human. The API call sitting underneath that is usually just the data, nothing else. Fewer bytes per request adds up fast when you're running thousands or millions of requests through paid residential or mobile bandwidth. That's real money either way, whether you notice it or not. So what does this actually look like when you go looking for it? On most modern sites built with a JavaScript framework, the page you see gets populated after load by one or more fetch calls to a backend. Sometimes that's a fairly plain endpoint returning JSON for a specific page of listings. Sometimes it's a GraphQL endpoint where the same single URL serves completely different data depending on what query gets sent in the request body. Sometimes it's a whole separate internal API living on its own subdomain with its own authentication scheme layered on top. And sometimes it's a server-rendered page that still quietly hydrates extra data in the background. Things like related items, reviews, or pricing that updates without a full reload. Some of these endpoints are meant to be public and are barely different from a documented API anyone could use. Others are strictly private, built only to serve the site's own front end, with no documentation and absolutely no promise that the shape won't change tomorrow without warning. Finding one doesn't automatically mean you should hit it directly. It means you now understand how the data actually moves. Reading the network tab properly is just using the browser the way it was built to be used. Nothing exotic about it. Open Developer Tools, go to the Network tab, filter down to HSR and fetch requests only, and then reload the page or trigger whatever interaction you actually care about. Paginating, filtering, searching. What you'll see is the real request as the browser actually made it. The method, the full URL, the query parameters, the request headers, and the response body sitting right there for you to read. The few things are worth checking closely in that request. First, the response shape. Is it a flat array of items? Is it a paginated wrapper with a next cursor field? Is it a GraphQL envelope with a data key and an errors key sitting alongside it? This tells you exactly how to walk through the entire data set instead of guessing at page numbers and hoping you covered everything, or worse, scraping the same data twice because you didn't understand the pagination pattern. Second, the query parameters. Sort order, page size, filters, they're usually sitting right there in the URL or in the request payload if you just look. A limit and offset pattern is a completely different iteration strategy than a cursor-based one, where you have to follow a token from each response to get the next page. Get this wrong, and your scraper either misses records or loops forever pulling the same page. Get it right, and the whole job becomes almost mechanical. Third, auth and session headers, and this is where you learn something about the target's actual intent, not just its plumbing. Some of these calls carry nothing more than a standard user agent string. Others carry a bearer token, a session cookie, or a custom header that gets generated client-side and rotates on a schedule. If a request needs a token that's minted fresh per session and tied to browser fingerprinting, or a short expiry window, that's the site telling you this endpoint was built to be called only from inside its own front end, not as a public interface. Treat that as information, not a puzzle to crack open. Fourth, rate and pagination limits. If a page size parameter caps out at 50 no matter how high you set it, that's the server telling you the real ceiling whether it says so anywhere or not. Respect that number. It's not a suggestion, it's the server drawing a line, and the scraper that ignores it and keeps requesting bigger batches anyway is announcing itself to whatever monitoring the site already has running in the background. Plenty of internal APIs use signed requests, rotating tokens, or headers computed by deliberately obfuscated front-end JavaScript, specifically so the endpoint is hard to call from outside a real browser session. That's a deliberate design choice by the site, not an oversight somebody forgot to close. It usually exists for the exact same reason bot detection exists on the HTML side of the same site, to keep automated traffic off a resource that wasn't built to handle that kind of load, or to protect data the business doesn't want redistributed wholesale to whoever asks. When you hit that wall, the honest options are the same ones that apply to any scraping target, AP or HTML, doesn't matter. Check whether there's an official documented AP with published rate limits and clear terms. Read the site's robots.txt file and its terms of service for what's explicitly allowed and what isn't. And if the data actually matters enough to your project, just ask the company directly. A lot of sites that lock down their internal AP will license the same data through a proper channel if there's a real legitimate use case behind the request. Trying to replicate a private token scheme byte for byte just to get around that lock isn't really a scraping technique at all. It's a fast way to get an entire IP range blocked, and a pretty solid reason for the target to tighten its detection even further for everyone who comes after you, including people running completely legitimate compliant scrapers against the exact same site. That cost doesn't land on just you. It lands on the whole ecosystem of people trying to access public data responsibly. Now here's the part people miss. Finding the APE is a data format win. It is not a traffic pattern win, and those are two completely different problems. Automated requests against a clean JSON endpoint still look automated to whatever is watching. Same request interval, same fixed header set, same total absence of the other page assets. A real browser would also be pulling in the background the images, the fonts, the analytics pings. Sites that bother building real bot detection generally watch both channels, the page loads and the APE underneath, because a scraper hitting only the JSON endpoint on a perfectly regular clock is its own kind of signature. So that's still a proxy and request shape problem, exactly the same as HTML scraping, no shortcuts there. Data center IPs on a known hosting range get flagged faster on sensitive endpoints because the network itself, the ASN, is a signal all on its own before a single request even happens. Residential and mobile proxies route through real consumer networks and read more like organic traffic at the cost of being slower and more expensive per request. Rotation policy still matters just as much. Hammering an AP endpoint from one single IP at a fixed interval is exactly the pattern rate limiters exist to catch whether the response comes back as JSON or HTML. What actually does change is your request volume and your error surface. Cleaner responses mean fewer parsing failures to debug at 2 in the morning, which means fewer retried requests, which is real proxy bandwidth saved over a long-running scraping job. That's the genuine win here. It's not that the API route makes you invisible. It just makes the job cheaper and steadier to run once the underlying proxy and pacing decisions are already right. Ora Prensi, not every site has an API worth finding, and it's worth saying that plainly. Server-rendered pages with no client-side hydration at all just don't have one. The HTML is the only representation of that data that ever existed anywhere. Some sites deliberately serve full HTML specifically, so there's no clean JSON contract for anyone to lean on. And some internal APIs are so tightly coupled to session state and rotating tokens that treating the rendered page as the stable interface is genuinely the lower maintenance choice, even if it means writing more code upfront. The point here isn't that the APA route always wins, because it doesn't. The point is, you should know which situation you're actually in before you commit a scraper's entire architecture to parsing markup that was never meant to be read that way by a machine in the first place. 5 minutes in the Network tab tells you which world you're building for. So before you write a single selector, run the checklist. Open the Network tab, filter to XHR and fetch, and watch closely what loads when the page renders or when you paginate through it. Note the response shape, the pagination pattern, and whether the auth headers are static or rotating on you. Check robots.txt and the site's terms for what's explicitly allowed on both the page and any documented API. If the endpoint needs a token you genuinely can't obtain through legitimate means, go look for an official API or a data licensing option instead of trying to fake your way past it. And whichever route you end up taking, apply the exact same proxy and rate discipline you'd use for HTML scraping, because that part never goes away. A sensible rotation policy, realistic request intervals that don't look like a machine on a stopwatch, and a proxy type that actually matches how sensitive the target is. Finding the API first saves you real time and produces cleaner data, and that part is genuinely worth doing on every new target. It doesn't remove the need to scrape responsibly, and it definitely doesn't make a lockdown endpoint fair game just because you happen to see the request sitting there in DevTools. I run the proxies behind real scrapers myself, and the full written guides and the proxy setups I actually use are at proxyscraping.org. Full written guides and tested proxy picks at proxyscraping.org, so go check that out, and if this was useful, subscribe for more.